Okay, so we're going to talk about cross-site scripting. So just so you know, there's just for your general reference, there's an organization just kind of dedicated, kind of like, like the standards organization for web security, and it's called OWASP. And they publish a top 10 web application vulnerabilities assessment. It's yearly, or maybe it's not yearly, but something like yearly. So you can see at the top is injection. So basically, does anyone know what SQL injection is? Or I guess in general, maybe database injection?
So I don't have a lot of experience with it, but I saw a great, there's a YouTube channel called Computer File that explains it really well. But essentially my understanding is if there's any sort of like text input, essentially you're trying to send SQL into the text input. And so if it's not validated or like there's no like checking, then essentially you can execute a query through a text input unintentionally and then like essentially gain access to the database.
Yeah, exactly. Does anyone else have? So yeah, so that's right. It's basically executing a SQL command that the developer didn't want you to execute or didn't envision you executing originally. And the way it works is because you basically have to accept user input if you want to do anything useful or interesting on the web. You're taking in user input, and if you don't process that input, then you're just, it depending on how things are set up, you're potentially saying, here's this little black box that someone has given you some input, and if you don't check it, you just move it over right here, and then it gets executed on your database. And obviously for most users that's not an issue, but if you know what you're doing, you can cause a lot of havoc. So you can do things like gain access. You can gain administrative access. You can get passwords. You can delete the database. You can do denial of service kinds of attacks. So there are a lot of things you can do, and it all starts with accepting user input and not checking it or processing it. So that's part of what validation is. And a lot of this is, I wouldn't necessarily recommend trying to do all of this yourself. It's a constantly changing thing. And so there's a whole ecosystem, obviously, it's a whole profession that involves trying to counteract these things. But in general, SQL injection is I give you input, you don't check the input, and then that allows me to run queries or execute SQL on your server. Okay, so what we're going to talk about SQL injection at the top, and then a little farther down is cross-site scripting. And there's a whole bunch of other vulnerabilities. You can just take a look at this if you're interested. Okay, so that's just a general overview. Sorry, 1 second. All right. So if we think about how, so we've actually, I think we may have done a couple of websites just from absolute scratch, just using vanilla JavaScript and raw SQL. But the way it works is, let's say you're entering, you have a website and you sell a bunch of stuff, and someone enters information to search for something in your database. So you have a form in your, the HTML you serve up to the client, and the user searches for, bathrobes or whatever. And so that string, you grab it out of the form, you make a request to your backend, and your backend handles that. And probably at some point in your backend, there's going to be something that looks like this. So it's going to have to be some kind of pre-built SQL query, and you're going to need to insert whatever that user input so you can do the search that the user wanted, right? You can't just have this self-contained closed off application because you can't predict what people are going to use. So if you want any kind of dynamic interaction, then you're going to have to deal with user input. So you'll probably have something like this. And if you grab this string, Nirvana or whatever, from that form originally, you're probably just going to place it right in there. So if you didn't check this, you didn't clean it or anything like that, then here's where there's an opportunity to execute SQL comes in. So here's an example using. So I mean, this is kind of just a dummy example, but you might have something like this in your backend where you have a function called make query. This is written in Python, and then you pass in something like this. And if you look at the documentation, let me see. So if you look at the documentation for the SQLite 3 module in Python, it tells you, I think there's some red down here. Is there red? I can't remember what this is, but it will, okay, here we go. Yes. So here's an example of what you shouldn't do. So this is an example, this is just string interpolation. So this is basically the same thing as what we have here, where we're just taking whatever string and we're plopping it down into that SQL command. So again, if you do that, then you're opening yourself up to certain vulnerabilities. So there are certain built-in protections you can use even with something like SQLite 3, but there's lots of other processing that you might want to do in order to protect yourself. So instead of doing that, you use this syntax, and that way it's more secure. Okay, so we'll see an example of that in the challenge for today. All right, so there are a few of these. It's kind of like a toy. So there are lots of automated services for looking for checking for vulnerabilities in your website, and this particular one has a dummy site that you can practice on. So this is a deliberately insecure site. So you can go in here and play around with stuff. So you can see some examples. There's lots of things you can do, and there's a link at the bottom of this section on the README where there's some examples you can play around with if you want to. We can do something like log out. So I'm gonna log in here just with this dummy account. So test. I'm gonna open up my developer tools. I'm gonna take a look at the network. So I'm gonna log in here. So there are a couple problems here. One, this is not HTTPS. This is not encrypted. So we're sending, I just sent my username unencrypted in the clear. We'll talk more about HTTPS later this week. And then relatedly, I'm getting a response which is not encrypted, which includes personal information. We can see that in the form data we have uname and pass. So we could potentially use some of that information. So I'm going to update this and check out this, so I can see all of my data here in the form. And again, I would have submitted this in the clear over regular HTTP, which is very easy to intercept and check. And we can also see that there are all these fields here, like you are name, UCC, you email, you phone, you address, and update. So there are all these fields, and so there are there are a number of issues here. One is we're sending secure information over HTTP, and we're also given this information about potentially about if there's a direct correlation between the naming conventions in our form and the naming conventions in the database. So I'm gonna just do one example here. So if we go to, let's go to, first off, we'll go to artists. And we go to artists equals 1. So we're familiar with query parameters. So we go here, we go to artists equals 1. So this is maybe not the best convention, depending on your position here, but we basically are given information about the database 1. So this is probably the ID of 1. You can also do something like return a blank result. And what happened here is that we actually made a valid query. There's just no results. So now we have basically an empty return value, which we can potentially use. We can also, if we make an invalid query here, we just made an invalid query, and rather than giving us some generic error message or redirecting us somewhere else, we get basically debug information from the server. So this is one reason why you don't want to run your apps in debug mode. So in Django and React, there's basically a development mode and a deployment mode or a production mode. So you want to make sure that you're not doing you're not deploying your apps in a developer mode, so you don't get these kind of information rich return values. So we have warning. So we see that MySQL fetch array expects parameter 1 to be resource Boolean given. So we get this isn't enough information for me to do much, but it's enough information for someone who knows what they're doing to take the next step. So I started out with no information, and now I know that this is a MySQL database. So it's not Postgres, it's not whatever. So there are some, although SQL, all flavors of SQL are kind of the same to a certain extent, there are also some differences, and there might be particular vulnerabilities or tactics that I know I can now try here, and I can eliminate some other ones. So I've just I've just reduced the amount of things that I have to try. And we're given this file structure, so maybe we can know something about what kind of server this is deployed on. We know where this particular file is, and we know the line number, which depending on what you're doing, may not be useful information. But in either case, this is not information that a normal user needs to have. So restricting that information is important. So this is kind of the most, in a sense, this is like the most basic SQL injection attack, where I'm making a query. It's maybe it's not really a query, but it's a query, and there's an error, so I'm getting information that I shouldn't have. There are also things you can do. So if you go back to this example, you can do something like true. So 1 and true have the same, the same value in SQL. So again, this is some more information that we might be able to use. Okay. So one, the server took a little longer to respond. So there are also attacks that rely on timing. So you send a certain query, it takes a certain amount of time. You send another query, it takes more time. So you can make, again, you're getting information, however indirect, about the server. So we can make a query to the database, which is now going to return nothing. And we can tack on stuff. So we can use union. So union basically allows you to combine commands. So I can write one SQL command, then union, and then another SQL command. So whatever right now, it's going to combine nothing with whatever the following query returns. So union select. Now this is like what fields you get back. This is something you'd have to determine by playing around, but I happen to know that this particular thing. So there are three rows that I can look for from. So there's a table called users. Again, I happen to know this, but this is not a hard thing to guess, right? A table called users. I mean, who would have thought? And then where so what I've done, let me go back. Maybe write that. Like this, it transforms it into the URL safe character. So union select star from star select 1, 2, 3 from, what is it, you name. So what I'm doing is I'm basically creating a null query and then joining that with the query that I actually want to make, which is select whatever these values are. Maybe I don't know what they are quite yet, from users, the table where uname is test. And I know that there's a user called test because I've already entered that in before. So I make this query and I can see that, so I don't know where the 1 is, but I can see that the information being displayed here, this is going to be the second, the second column, and this will be the third column. So we can start basically playing around with things. So I'm going to go over here, like this. I'm going to go back to the user login. This will take a minute. Maybe I'm being blacklisted here. Okay, well, that's inconvenient. But if you may recall from the form, we got all this information about all these fields. So that's one way where we might take that as a jumping off point for guessing what column names might be. So you can do something like, yeah. Sorry, I don't know why this is deciding to not work right now. Okay, why don't why don't I skip this for now and talk about SQL cross-site scripting. This is not going to work real without this as an example. Okay, so let me continue on.
Chad. If someone really hacked it bad, it broke it. So it resets every so often.
Okay.
Like this happens all the time. So if someone else was on the machine and they decided to like annihilate the free machine to test, then you have to wait for it to reboot itself because it's all messed up now. It's a problem when you do shared hacking on stuff. So it's pretty common. Just give it 10 minutes and come back. It probably has a retimer.
All right, cool. So we're going to continue on with cross-site scripting. So cross-site scripting is like well, it maybe is to a certain extent dependent on SQL injection. So SQL injection, when you do a SQL injection attack, it's usually kind of an end to itself. So I want to get some information from the database, so I do this attack, and then I get the information and I'm done. Or I get access to the I get access to the database admin user, and I can do stuff on the database. But that's it. So cross-site scripting, there's a little bit more indirection. So the idea with cross-site scripting is I have some kind of malicious code, and I basically want you, web server, to give that content out to everyone who uses you, right? So I want Facebook to put my link on their site so that other people will click on it, and then whatever happens. So cross-site scripting, there's a two-step process. One, I have to get my malicious code onto the server, and the server has to serve that up to end users, and then oftentimes users have to do something like click on a link in order for that whole process to be completed. So it's a little bit more complicated, but we can actually do this one locally, so we don't have to depend on. Okay, so I'm just going to go through. This is just kind of, some very basic JavaScript stuff, which we already know, right? So I'm going to do some stuff here. Open the dev tools, go into the console, and write some JavaScript that calls alert, and then it looks as though Google is giving me a pop-up. Of course, this is all just happening locally on my machine. No other Google user is seeing this. But if I somehow put this on, I got this into Google servers, and then they serve that up, then everyone who accessed google.com would see this alert, and they would think it's from google.com. All right, so we can go through some more JavaScript stuff. So I've just basically overwritten everything on the page, and we'll add this image here. So there's a third party. So what I'm doing is I'm writing to the document, and I'm inserting this image tag. So this is all just text, but of course it's valid HTML. So it'll be inserted into the document. And then if I look at the elements, I actually have this image tag here. Okay, but that doesn't always work out so well. So there's some protection here. So this is going to depend on a lot of factors, but so not everything works. You'll see this when it's the challenge. SQL injection in theory is pretty easy. In practice, it's kind of difficult unless you really know what you're doing. We're using tools. All right. So all that stuff is fine, but what we actually want to do is insert a script, almost certainly. We want to insert some kind of script. So we can create a script element. And then here, we're going to, so we've created an element and then we've filled in that element. So now this, what we've put right here is JavaScript. So we created a script tag and we put JavaScript inside of the script. And then the last step, of course, is to actually put that script tag in the HTML. So we do that. We can see that this actually was console logged. So this JavaScript was executed. If we go to the elements tag, we can see in the head that we actually have this script tag right now. So we've inserted this script tag, which is going to execute JavaScript, which can affect how the page looks and behaves and so on. So that's all locally, but our goal is to write something that affects the page in the way we want, which is going to be something malicious, but to also, the real problem is getting that onto a host server, basically without people knowing. So the challenge for today, let me just double check and see if this is. Still not working. All right, well, let's talk about the challenge for today. So there's some setup that's involved. If you have any issues with this, just let me know. There's going to be, it's basically a two-parter. One is the Sql Injection challenge, which fortunately this is not working right now, but the Sql Injection challenge. And the second one is going to be a cross-site scripting challenge. So you're going to have to clone the repo, create a virtual environment, activate it, and then install whatever modules you have to install. And then you're going to execute this script. There's a bash script in here, which is going to execute some commands and get everything up and running. That's there's already a database in there, but ideally you will be breaking this database as you do the challenge, and the solution will be to break the database. And if you do that, if you get stuck and you break it, but it's not quite broken in the right way, you can just run this. You can delete the database and run the script again, and it will recreate it. So as you do this, you should take a look in the source code. You can see that it's badly written in lots of ways, and there are a couple comments to point you in the right direction. So another thing I'll say that in some ways SQL injection is easier if you're just using a database. So if you're using like the DB browser or whatever you're using, you can execute. You can have a database. You can execute commands, and you can kind of see how some of these things work. You can practice some union statements and things like that. It's tougher on the web because you have to deal with quotes basically. So there's an issue of how many quotes do I need? Do I need a single quote or double quote, or a single quote then a double quote? So it's just this kind of minutia involved in actually getting the SQL injection to work properly. So you'll have to look around in the source code, see if you can identify where the problem area is, and then go to the web application and then play around and see if you can get it to work. For the second challenge, it's similar. except you're going to have to not just execute a SQL query, but you're going to have to write some JavaScript, HTML JavaScript, and then get it inserted into the database. And in order to get this running, you're going to have to run an additional server, which is going to act as like the bad guy server. So you'll have your application server, which is serving you the application you want, and then you'll have this additional server where you'll get sent the where your private information will get sent to. So that's the basic idea. It should be yeah. This is still down. Oh, there we go. Nice. All right, so let me let's jump back to let's jump back up here. All right, so we were taking a look at the user. Let's see if this comes back. We go to sign up, and then I'm going to do test. I'm going to take a look at this network. I'm going to update this and check out. So here I have all this form data with the labels. So something like this is a good jumping off point for guessing what columns could possibly be named. Now, there's no guarantee, but it's it's a good guess. It's a good place to start. I'm going to go back here. Okay, still doesn't want to work. All right, I don't want to just indefinitely waste everyone's time here. So even when it does come back up, I can let you guys know and try to do a quick demo. But the basic idea is that you'll want to, I mean, for this particular example, the example that you'll do for the challenge is simpler, but what you can do is do union and then take a look at those three columns, start guessing about what the values might be based on here, things like UR name or uname or R name or whatever, UCC, CC, email. You can start doing things, and then if you execute these queries, you can play around with it, and you can actually get, you can actually see, you can get all this information for a given user. So yeah, I apologize about this. Maybe next time I'll use I think they have a Docker image, so I should do that next time. All right, so I'm going to stop here.